Hello everyone. Today we are going to discuss about triangle chapter where we'll be talking about similarity of triangle. In our last session we have discussed about the basic definitions of triangle. Then we also discussed about the basic proportionality theorem, the converse of it, and also we saw how we can solve questions based on it. In today's class we'll be seeing that what are the different similarity criterias are. So let's start with the topic. First, we'll talk about some of the theorem where we'll not be talking about the proof of it, as the proof of it has not been important in the last few years, and now recently it has been deleted from the NCERT syllabus. We only need to study about the definition of it, and we need to understand that how we can apply these theorems while solving questions. So let's talk about the first theorem here. The theorem says that if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio, and we can say that the two triangles are similar. This criteria is known as AAA criteria, which is called angle criteria. So what we are going to learn in this particular theorem is that suppose A, B and C and P, Q, R are two triangles such that if angle A equals to angle P, angle B equals to angle Q, and angle C equals to angle R, then we can say that therefore triangle ABC is similar to triangle PQR. Remember, in this case, as we all know, that here A corresponds to P and P corresponds to A. B corresponds to Q and Q corresponds to B, and C corresponds to R and R corresponds to C. So this corresponding relation we have to maintain while writing the similarity, as we have already studied congruency part. So I hope this will be clear to you all. Now when we talk about the next theorem, which is if two angles of one triangle are respectively equal to two angles of another triangle, then again we can say that the two triangles will be similar, and this criteria is known as AA criteria. Now how we can say this will be true? That we know that by angle sum property, if you check, we can say that angle A plus angle B plus angle C is 180 degree, and also angle P plus angle Q plus angle R is 180 degree. Let's name the triangles, that is A, B, C and PQR, with respect to which we are talking about here. Now if you consider here, if I'll say that any two of the angles of both the triangles are equal, then we can say by angle sum property that the third angle will also be equal, and so again we'll go back to the AAA criteria and we can say the triangles are similar. So here in this case, if we are saying that angle A equals to angle P, angle B equals to angle Q, then by angle sum property what will happen is angle C will be equals to angle R, and we can say therefore triangle ABC is similar to triangle PQR by AA criteria. This is the second theorem. Third theorem says that if in two triangles sides of one triangle are proportional to the sides of the other triangle, then the two triangles are said to be similar and their corresponding angles will be equal. So what it means is that if A, B, C and PQR are two triangles, and we know that if AB upon PQ equals to BC upon QR equals to AC upon PR, then we can say that the triangle ABC is similar to triangle PQR, and following which, as the triangles are similar, we'll be able to say that their corresponding angles are equal, which implies that angle A will be equals to angle P, angle B will be equals to angle Q, and angle C will be equals to angle R. So this is side, side, side criteria, where sides of one triangle are proportional to the side of another triangle. Next theorem is that if one angle of a triangle is equal to one angle of other triangle and the sides including these angles are proportional, then we can say that the two triangles are similar, and this criteria is known as SAS similarity criteria. That means side angle side. What it means is that if A, B, C and P, Q, R are two triangles such that it is, suppose AB upon PQ equals to AC upon PR and included angle A equals to included angle P, then we can say that triangle ABC is similar to triangle PQR. What we have done here is angle A and P we have taken equal, whereas AB and PQ are one of the corresponding sides and AC and PR are other corresponding sides which are proportional. So we can say that the triangles are similar. And following which, again further we can say that if the triangles are similar, therefore angle B will be equals to angle Q, angle C will be equals to angle R, and then following which all the corresponding sides will be also proportional. So these are some of the theorems based on which we'll be solving the question from similarity of triangles. Now let's start with the first question, which is a girl of height 90 cm is walking away from the base of a lamppost at a speed of 1.2 meter per second. If the lamp is 3.6 meter above the ground, find the length of her shadow after 4 seconds. So what the question is that, let us suppose that here AB represent the lamppost and the girl is moving away from the lamppost. So at some instance, if the girl is at CD, then we have to find out what will be her shadow length. So for that, we will make this point E. Now here, we also have to find out that in 4 seconds, what will be the distance traveled by the girl. So we know distance is equals to speed into time. So here the speed is 1.2 meter per second and the time is 4 seconds. That means she will cover 4.8 meter in 4 seconds. That means here AC will be 4.8 centimeter. The height of the girl is 90 centimeter, which we can write 0.9 meter, and the height of lamp is 3.6 meter. We have to find the value of CE, which is the length of shadow. Now, in order to find that, we are going to take the help of similarity. If we'll take in triangle ABE and triangle CDE, what we observe is angle A equals to angle C, which will be 90 degree, and angle E will be equals to angle E, that is common in both the triangle. So by AA similarity criteria, we can say triangle ABE is similar to triangle CDE. And since the triangles are similar, we can say their corresponding sides will be proportional. So we can say therefore AB upon CD equals to AE upon CE equals to BE upon DE. Now substitute the value, but we'll be substituting the value in those two expressions whose value is given and whose value we have to find. So here we know the value of AB, we know the value of CD, we have to find the value of CE. So we'll be taking these two equality and we'll be solving it. So now what we'll do, we'll take AB upon CD equals to AE upon CE. If you substitute the value of AB is 3.6, CD is 0.9, which is equals to AE. AE will be how much? That will be 4.8 plus CE upon CE. On solving it, what we'll get is, this will be 4, because 3.6 upon 0.9, it will be 4. This will be 4.8 plus CE upon CE, which will be equals to 4 times CE equals to 4.8 plus CE. Now that we can write it as 3 times CE equals to 4.8, and so the value of CE will become 4.8 upon 3, which will be 1.6 meter. That means the length of the shadow of the girl at that time will be 1.6 meter. Moving to the next question, which is that in the given figure, it is given QR upon QS equals to QT upon PR and angle 1 equals to angle 2. We have to show that triangle PQS is similar to triangle TQR. So let's solve it. In this case, if we'll check in triangle PQR, it is given angle 1 equals to angle 2. So that means this triangle is an isosceles triangle, and so sides opposite to equal angles will be equal. So we can write it as opposite to angle 1, it is side PR, and opposite to angle 2, it is side PQ, and that is equal. Now we'll take the given statement, which is QR upon QS equals to QT upon PR. Now in this case we have QR upon QS, and which is equals to QT upon PR. Here we can write it as QR upon QS equals to QT, and PR we can replace it by PQ, as we know that PR and PQ are equal. Also, angle 1 is common in triangle PQS and triangle TQR. Therefore, we can say that triangle PQS is similar to triangle TQR by SAS similarity. Let's move to the next question. In this question, we have that in the figure 6.37, it is given that triangle ABE is congruent to triangle ACD. We have to show that triangle ADE is similar to triangle ABC. So in order to prove it, we'll take the given statement that since triangle ABE is congruent to triangle ACD, that means we can say their corresponding parts will be equal. So therefore, we'll have AE equals to AD, and we'll also have AB equals to AC. Now we can write AB as AD plus DB, which will be equals to AC can be written as AE plus EC. Now here we know that AE and AD are equal, so we can cancel it. We'll get the value as DB equals to EC. Now from this, what we understand that if I'll take this one as 1 and 2. So if I will divide 1 by 2, what we'll get is, we'll get AE upon EC equals to AD upon DB. And so by converse of BPT, we can say that DE is parallel to BC. Now, if we'll take in triangle ADE and triangle ABC, what we observe is angle ADE equals to angle ABC, since DE is parallel to BC. And also angle A equals to angle A, that is common. Therefore, we can say triangle ADE is similar to triangle ABC by A criteria. Next question is, that is given that A is a point on the side AD produced of a parallelogram ABCD and BE intersect CD at F. Show that triangle ABE is similar to triangle CFB. Let's prove it. So we'll draw a parallelogram ABCD. So it is given that AD produced of a parallelogram to E, which intersect CD at F. Now, what we have to prove is, first of all, given part is ABCD is a parallelogram. We have to prove that triangle ABE is similar to triangle CFB. Now to prove it, we will take these two triangles, that is in triangle ABE and triangle CFB, angle AEB, that will be equals to angle FBC, as it is alternate interior angle. As we know that in parallelogram opposite sides are parallel, so AD will be parallel to BC, since AD is parallel to BC. Also, what we observe is that angle A will be equals to angle C. As we know, opposite angles of parallelogram are equal. So therefore, we can say that triangle ABE is similar to triangle CFB by AA criteria. Moving to the next question, which says that sides AB and BC and median AD of triangle ABC are respectively proportional to the sides PQ and QR, and median PM of triangle PQR show that triangle ABC is similar to triangle PQR. So here we have two triangles A, B, C and P, Q, R. Then we have AD as a median, and we also have PQR triangle where PM is a median. Now the given statement is that AB upon PQ equals to BC upon QR equals to AD upon PM, and we have to prove that triangle ABC is similar to triangle PQR. In order to prove it, what we'll do is we'll take the given statement, that is AB upon PQ equals to BC upon QR equals to AD upon PM. And now we'll be writing it as AB upon PQ. Now since AD is the median, that means D is the midpoint of BC. So we can write BC as 2 times BD. And similar way, M is also the midpoint of QR. So we can write QR as 2 times QM, which is AD upon PM. Now we can cancel 2 and 2. We'll get AB upon PQ equals to BD upon QM, which is equals to AD upon PM. This means we can say that triangle ABD is similar to triangle PQM by SSS similarity criteria. And since these two triangles are similar, we can say therefore angle B equals to angle Q. Now we'll take in triangle ABC and triangle PQR, and we can see that AB upon PQ equals to BC upon QR, which is given, and angle B equals to angle Q, which we have just proved now. So therefore we can say triangle ABC is similar to triangle PQR by SAS similarity criteria. Moving to the next question, what we are getting here is that sides AB and AC and median AD of triangle ABC are respectively proportional to the sides PQ and PR, and median PM of triangle PQR show that triangle ABC is similar to triangle PQR. So let's prove it. For this again, we are going to draw two triangles. So given is AB upon PQ equals to AD upon PM equals to AC upon PR. Required to prove is triangle ABC is similar to triangle PQR. Now in order to prove this, we are going to draw construction. So what is the construction here is produce AD2 S and PM2 T such that AD equals to DS and PM equals to MT respectively. Join BS, CS, QT and RT. After doing this construction, we'll move towards the proof part. So in the proof, what we'll say that in quadrilateral ABSC and PQRT, diagonals bisect each other. Therefore, ABSC and PQTR is parallelogram. Now, since it is a parallelogram, we know that in parallelogram opposite sides are equal, and we are going to use those concepts here. Now, we are going to prove here first that triangle ABS is similar to triangle PQT, and similarly triangle ACS is similar to PRT. Before we proceed further, we'll assume this particular angle as 1, this has 2, this has 3, and this has angle 4. Now, we will take triangle ABS and triangle PCT and prove that they are similar. So how we'll do that? In this case, we'll take that we know that AB upon PQ equals to AD upon PM equals to AC upon PR. Now if we'll multiply 2 to AD and 2 also into PM, what we'll get is, we'll get AB upon PQ equals to 2 times AD upon 2 times PM equals to AC upon PR, which will give us AB upon PQ equals to 2 times AD will be AS and 2 times PM will be PT equals to, we can write in place of AC, we can write it as BS, and in place of PR we can write it as CT. And so by SSS criteria we can say therefore triangle ABS is similar to triangle PQT by SSS similarity criteria. That means we'll have angle 1 equals to angle 3. Take it as 1. Now similarly, we can prove that triangle ACS is similar to triangle PRT, and so we'll have angle 2 equals to angle 3, that is the second statement. Now adding first and second, we'll get angle 1 plus angle 2 equals to, this will be 4. We'll get angle 1 plus angle 2 equals to angle 3 plus angle 4, which will give us angle BAC equals to angle QPR. Now using that, we'll prove that the triangles are similar. So now what we are going to do, we are going to take the triangle ABC and triangle PQR. We know that already that AB upon PQ equals to AC upon PR, and now we know that angle BAC equals to angle QPR. So therefore we can say triangle ABC is similar to triangle PQR by SAS criteria. And this is how we can prove this particular question. I hope it is clear. Now here I have not proved the similarity criteria. We have just seen the statement of it. But if you want me to discuss the proof of those similarity criteria theorems, then you can let me know through the comment box, and I will try to make a separate video which will be based on how those similarity criteria can be proved. Thank you. Take care, everyone.